Hello. Today I'm going to show you how to convert base 10 numbers into binary. I'll show you the regular way first, and then I'll show you a shortcut that might make things easier for you in the future. Typically, you'd start by dividing the number by 2 first, and then you get the remainder. So 348 divided by 2 is 174. There's no remainder, so remainder 0. Then you do the same thing to your newly divided number here, so 174. So 174 divided by 2 is 87, and likewise there's no remainder. Now this is an odd number. If you divide an odd number by 2, you're obviously going to have a fractional part, which is going to be 43.5. Now, how do we get the remainder from this number if we have a fractional part? That's actually quite simple. So first, we would separate the whole number in the fractional part. So we have 0.5. And then, to get the remainder form, you would multiply the fractional part by the divisor, which in this case is 2. So 0.5 times 2 is just 1. So we know that the remainder is 1. Now obviously this is binary. The remainder is always either going to be 0 or 1. So now let's continue. Again, we take the 43 here, and then we divide it by 2. That's going to be 21, with the remainder 1, again, like we did earlier. That would usually be 21.5, but we convert the 0.5 into a remainder, so 1. So next we take 21 again, and divide it by 2, and then we get 10 remainder 1. Then 10 divided by 2, that's going to be 5 remainder 0. 5 divided by 2, that's going to be 2 remainder 1. And then 2 divided by 2, that's going to be 1 remainder 0. And then now you're probably wondering, okay, now that we have a 1 here, I don't think we can divide that anymore. But actually, we can. We take that, and then we still divide it. So that's going to be 1 divided by 2. That's going to be, well, 0. You can't divide 1 by 2. You're just going to get 1/2. But 1/2 is equal to 0.5. So we can get a remainder from that. So that's just going to be 0 remainder 1. Now that we've reached 0, we can start actually converting to binary. So what you would do is you would get the last remainder like this. So there was a reason we were writing it this way. You would get the last remainder, and then you would start writing them from left to right. So our last remainder here is 1. So we would write 1. And then we have 0, 1, 0, 1, 1, 1, 1, 1. Okay, now I'll just copy this. This is our base 2 form or binary form of the number 348. Okay, now earlier I said that I'll be showing you a shortcut to convert base 10 to binary a little bit faster. This could work with smaller numbers or bigger numbers. It's really up to you. So the trick is remembering that binary numbers have a pattern, and that's just the powers of 2, right? But in this case, we'd be starting from right to left. So we'd write our first number, then second, third, like that. Now, let me show you the pattern. So pretend that this is a binary number. All zeros mean this is just equal to 0. But remember the pattern of the powers of 2. 2 raised to 0 is just 1, right? 2 raised to 1 is 2. 2 raised to 2 is 4. And 2 raised to 3 is 8. So on, so forth. And then if you take a look here, we can apply the same concept for converting binary. And then I'll just put these up here. I'll use a different color so you can see. 0, 1, 2, 3, 4, 5, 6, 7. So let's say 2 raised to 7, that's just 1, right? That's going to be 2, and that's going to be 4, 8, 16, 32, 64, then 128. Using this knowledge, we can actually compute for the numbers that we need to add up. So let's remember 348 here. So let's just say here, I'll put it here. And then I'll write, this is going to be 2 raised to 8. Next, let's go to a lower number. Obviously, just by looking at 128, if we add that to our 256, that's going to be much too large for 348. So let's just write a 0 there. But I do think we can fit our 64, which is just going to be 2 raised to 6. So let's write 64 here. Next, I think, just by looking at it, we can't exactly fit 32 either. So let's add another 0. But what we can do is probably a 16, right? So let's write our 2 raised to 4 there. So that's going to be 16. Now, just by looking at this, 256 plus 64 plus 16, that's 336. That's going to be 336 for right now. And then looking at this, we only need 12 more, right? We only need to add 12 more. So by looking at the pattern here, we know that the numbers that we need are 8 and 4. So let's just write our 1 and 1 here. And then for the remaining decimals that we don't have here, for the remaining binary digits that we don't have, we can just have zeros. And then if we add all of these up, 256 plus 64 plus 16 plus 8 plus 4, we would get 348. So we still get the same number even though we didn't actually do the process. Now, this is a little tedious if you haven't memorized the powers of 2 and can't really do mental math much, but you can use this process to convert from binary to base 10 a little bit faster. Now, I'm going to show you the earlier technique and then apply it on how to convert binary to base 10 this time. And I think using this method is much easier than doing the usual. So, because it's basically the same thing, except you don't have to write out every single digit and then go from there. All you have to do is just imagine the powers of 10 on these guys' heads. So we usually start from 0 here. That's 0, 1, 2, 3, 4, 5, 6, and then 7. So let's start from the largest because I think that's easier. 2 raised to 7 is 128. So 2 raised to 7. Remember, we're counting from left to right here. So 2 raised to 7, it's 128. Plus our 6, that's going to be 64. Then we have our 5, 32. We skip the 4. So 2 raised to 3, that's 8. Plus 2, that's 4. And then 2 raised to 0. What do you get when we have 2 raised to 0? Well, we know that from the laws of exponents that 2 raised to 0 is going to be equal to 1, because any number raised to 0 is automatically going to be 1. So let's just write our 1 there, and then let's add them up. 128 plus 64 plus 32 plus 8 plus 4 plus 1. That's going to be 237. And we can check this using the regular method as well. So let's do the regular method here. So 237 divided by 2 is going to be 108.5. So remainder 1. 118 divided by 2 is going to be 59. Remainder 0. 59 divided by 2 is going to be 29. Remainder 1. 29 divided by 2 is going to be 14. Remainder 1. 14 divided by 2 is going to be 7. remainder 0. 7 divided by 2 is going to be 3, remainder 1. And then 3 divided by 2 is going to be 1, remainder 1. Then 1 divided by 2 is obviously going to be 0, remainder 1. Now let's line these up. So we have our 1 here. So 1, another 1, 1, another 1, 1, 0, so 0, then 1, 1, so 1, 1, then 0, 1. And as you can see, this is the same as this. 1, 2, 3, right? 1, 3 ones. 1, 1, 1, 0, 1, 1, 0, 1. So that means our answer of 237 is correct.